Good morning. Um, yeah. So till last class we were discussing about SQL Server architecture, right? So how that works, So how what are all components, major components, and so how that works. Basically, the SQL Server architecture. What are all components we have in this architecture, and we have learned now. So the next part is SQL Server OS operating system. um so we'll learn SQL Server operating system to understand, like, so how that works, the operating system. So how SQL Server architecture, and whenever you execute any queries, how that will be going through and execute the queries on the CPU, right? So we will discuss about that. So what we will learn, so these are all points that we will learn. So we will discuss more in detail of these areas. So scheduling. So scheduling is nothing but so executing on the CPU, how the threads will be executing, how the queries will be executing. So we will be so understanding, and we'll learn here, right? Then preemptive versus non-preemptive. So what is preemptive, what is non-preemptive scheduling? So we will discuss what is UMS and what is the main purpose of UMS. We'll discuss, and troubleshooting some UMS related issues, right? Cool. So but before so we even start, we should understand the basics of the discussion, right? The basics we should understand. So we keep on talking about the process, right? So if you so if you work on any of the performance issues, so this is key important. Like for example, let's consider um, any performance related issues. So you need to understand whether SQL Server process is an issue or not, right? So process is a, you can consider process is a executing program, right? In simple terms, it is an executing program. For example, let's say we have written a C code, C program, or C++ or Python or whatever it is. So if you've written a code, it is not a process. So if you written a code and convert that code into an executable .exe, right? For example, let's say you've written a C program in a notepad, right? So C program you can written in a notepad, and you save that notepad into .exe file, right? Executable file. If you if you save that file into .exe file, and if you start executing that exe, then it is called a process, right? So process is a executable or executing program on the operating system, right? So whenever you execute a program, so that process will not execute on its own, right? So whenever you run process, so that will not execute on its own. We have multiple threads. We will talk about threads and so my details later. But for now, understand, process itself will not execute. So process, whatever we have written, right? For example, let's see, you can consider so you can consider anything. For example, let's say um, in a C++ or SQL Server.exe, whatever language you have written, right? Um, so hash include for x equal to y, x equal to 2, y equal to 3, z equal to x plus y, or whatever simple so program, whatever it is. So you have written a simple C code or whatever simple code, and if you execute, we need to understand x equal to 2, y equal to 3, so g equal to x plus y, 2 plus 3. How this will be executed? Some some worker or someone has to execute this code, right? That code execute, I mean, whoever executing the code, we call it as a thread. In other words, we call it as a worker, right? For example, let's consider a house construction. So if you are constructing a house, so we have a complete plan, right? So whoever builder, he created a complete plan to construct a house. But who will construct the house? Builder will not construct, right? So builder will arrange few workers to construct the house. The same way, so this executable, this process will not execute on its own. So it needs some workers to execute. So in other words, threads to execute, right? So that is the same thing. A process is an executable program. For example, let's say you have SQL Server, task manager, details, whatever, right? So these all are processes, right? So including Notepad is an executable, it's a process. SQL Server is a process. Notepad is a process. Whatever process we are executing on this computer, whatever program or whatever executable we have on this computer, we call that as a process, right? So everything I'll relate to the real-time scenario. For example, let's say, as I told you, like, so if there is a high CPU utilization, you need to understand the high CPU utilization is because of SQL process or not, right? So you should understand high CPU utilization because of SQL process or not. So how you will check that? So I will just quickly open that performance monitor and I'll show you how it looks like, right? So for example, if you open performance monitor, this is the tool that we will be discussing more into later on. But for now, just I'll show you what is the process and how that process is related to our day-to-day activities, or when we talk about any issues or something. Right? Just go to some right click, add counters, go to the same, right? Process, processor. I will talk about processor for now, process, right? So this is the process. If you expand this, or if you click here, so these all are processes that we have, right? These all are processes, whatever executables which are running on the computer, these all are processes. For example, let's say I want to see user time, right? So user time, I mean, we will discuss more about, but for now, understand that this is one of the counter, right? So we'll have to see how much CPU has taken for SQL process, right? So just type SQL, you have this SQL Server, SQL agent, everything you have here, SQL Server. So whatever SQL instances you have here, so you will have those instance details, right? But here you don't see which instance you are checking, right? I will tell you which instance, how you will identify this instance name or instance details, right? For now, just check this SQL Server is utilizing, so around whatever CPU utilization, right? So this is what. So that we will discuss more about CPU troubleshooting and CPU utilization later. But for now, understand that's the process and the further discussion. Right? If you have any questions, stop and ask me so that I will try to explain in a better way. Right? So process, as I said, process will not execute on its own. So we have n number of threads, and those threads will execute and finish the task which we have in the process, to complete the process, to execute the process. Uh, so whatever inside the process we have, so those will be executed by the threads or workers. What is thread? Thread is a basic unit which the operating system allocates processor time. So what is processor we will discuss, but for now understand it is a basic unit of executing your task, your work, the process work. A thread can execute any part of the process code, as I told you, right? So this is simple code or logic. So the process or the thread can execute any line of the code, any part of the code, right? So it depends on what what time the thread is created and what thread is executing. It depends on that, but it can execute any part of the code, right, including parts currently being executed by another thread. For example, let's say for example, parallel execution. So parallel execution, if multiple threads executes to run your code, right? So likewise, it is your this part is related to some kind of parallel execution or parallel query and all. Then what is processor? Processor, in other way, you can consider this as a container, right? So container is nothing but it is in other words, it is a hardware where we have, so CPUs, um, like where we have so threads will be executed in the container, right? So you can consider this as a processor, this as a process, right? So so this as a process, and we have a number of task or a number of line of code we have, and this will be created a thread or worker. So I'll tell you why we call it as a worker or thread, and this thread or worker will execute on this processor, right? So this thread execute on the processor is nothing but your hardware CPU. This is, let's say you have two processors, two CPUs, CPU1, CPU2, right? So this thread will execute on the processor. That is the reason we mentioned here somewhere, a thread is a basic unit to which the operating system allocates processor time, right? So operating system, it will allocate a processor and that thread will execute on the processor, right? That is the definition of the processor. And scheduling. So why so these are relevant or related in our so as a DBA, because for example, let's say you need to understand, so which processor, right? So let's consider the same scenario. You have CPU utilization, you need to identify the processor details as well. Add counters. So I have 4 CPU processors, right? So how to get that? Task manager, performance, CPU, and I have 4 processors, logical processors. I have 4, right? So you have something called processors, and where we see 0, 1, 2, 3, right? Processor will start from 0 to maximum, whatever we have, right? So again, you can see here that user time, and you'll have to identify which processor consuming high amount of CPU utilization, right? So we will discuss in detail, but if you see here, all processor equally distributing the load, right? So whatever you see here, all are almost equal. We don't see anything else, anything is high, anything less, but you can see here almost all are unequal. So that is the reason whenever there is a performance issues or especially high CPU utilization, so you'll have to check this processors and process to identify which processors are utilizing high, and how many processors we have, and which process is consuming high CPU utilization, right? So scheduling in other way, like, so whenever you want to execute your query, so operating system will decide when to run this query on the CPU, right? Operating system will decide when to execute my thread or worker on the CPU. That is called scheduling. So just normal scheduling. If you talk about SQL language, so we have a scheduling, right? In jobs, SQL jobs. So we as a so job creator will decide when to execute that job. So likewise, for this threads or worker, especially threads, I'm talking about threads, uh, it will decide, operating system will decide when to execute those threads on the CPU, right? That is the simple, this is the definition. CPU scheduling is a process that allow one process to run, use CPU while the execution of another process is on hold. What does it mean? So this is CPU. So if you schedule the CPU, if you as in like operating system schedule the CPU, it will run on the CPU. The thread will run on the CPU. It will allow to run only this thread is come out of CPU, right? At a time, multiple threads cannot run on the CPU. At a time, only one thread can run on the CPU. We will discuss that more on, like when this thread will come out of CPU and all. But for now, understand only one thread can run on the CPU at any point of time, right? So let's say, for example, you have 4 CPUs, right? So if you have 10 threads created for whatever reason, and at any point of time only 4 threads can run on the CPU at any point of time, one thread per CPU, right? So we will discuss more about how that works, going forward. For now, understand that scheduling is that operating system will decide when to run that thread on the CPU. What is yielding? Right? So yielding is not a operating system or SQL terminology. It is in general. So yielding, right? So for example, let's say you keep on talking, right? If you are keep on talking, you are not allowing other to speak. Let's consider it's a group discussion, right? So group discussion where we have multiple people, right? If you are keep on talking, when you will allow other to talk in the discussion, right? So you will not allow other to talk in the group discussion. It is not ideal, right? So you should allow other to discuss. Then you either you will stop on your own, or I mean, so you should stop on your own so that others will talk, or some so um, someone will be there, right? So to monitor the group discussion, either whoever it is, like either your manager or your so whoever moderator, so he will be there. He will ask you to stop. Two things, right? Or someone will initiate their discussion, then you will stop, right? At any point of time you will have to stop so that others can other will get their chance to talk. So the same way, yielding is nothing but one thread is spawned, right? It is, if it is keep on executing, so when this will allow other to run, right? So this will not allow, this thread is keep on running here on the CPU. So if it is not coming out of CPU, then it will not operating system cannot schedule other threads to run on the CPU, right? It's a keep on executing. So that is where we have yielding. Yielding is nothing but a thread is come out of CPU. Thread is either yield, or yielding is nothing but come out of CPU. right? Stop there and come, right? Like the same way in group discussion. Yield, thread yield or come out of CPU. When a thread yields the processor, yielding is nothing but come out of the processor, the system immediately allows another active thread, right? Another thread will, so it schedule another thread to run on the CPU. So same CPU. For example, here we have two threads in the line. One thread is executing, so total three threads. If it is coming out of this CPU, then another thread will go and will execute on the CPU. Once this is comes out, then another thread will get a chance to run on the CPU. That is how the yielding works. Why this is important? If you are already working, you must have heard non-yielding or deadlock scheduler scenarios, right? Non-yielding. So non-yielding is because of this. Non-yielding, a thread is not yielding from the CPU. Then what will happen? It is stuck, right? The scheduler is stuck. Then you must have heard non-yielding scheduler dump, right? So or stalled thread, so dispatcher dump. So those kind of dumps you must have heard, right? We will talk those as well, but for now understand, yielding is something, it is coming out of CPU. The thread is come out of CPU, so it will allow other thread to run on the CPU. So any questions? Right. So in just a pictorial way, so this is the process as an execution unit. I told you. So we have multiple tasks, right? So a process is a collection of multiple piece of code, multiple lines of code or multiple tasks, where a threads, I mean, I told you, right? Process will not execute on its own. So it contains multiple threads to execute the code, right? So this we will talk, right? Process is just a container. So we have already discussed, and process does not execute or run, rather threads associated. So we have discussed several individual tasks that, yeah, that's done. Let's talk a few words about, so how the query works, right? So in other ways, so I'll just give you um, this line. Maybe this is helpful, better way, right? So let me know if you cannot see. Okay, let's consider, so right, so we discussed about architecture and we discussed about, so how that works whenever you execute a query. Let's consider, mm, let's consider it is a some application query, right? So whatever queries we are executing, let's say it is a select query or insert update, whatever queries we are executing. So I'm not talking about how that executes and get the data, because we already discussed that in the architecture. Let's consider this is your application or user who is executing some queries, right? So you can consider any queries that we are executing from the application. So what will happen whenever you execute a query? That query is converted, or we consider that as a request, user request, right? So whenever user is requested, what will happen? That will be allocated or assigned to a task, right? So a task will be created and the request will be assigned to that task. So as soon as the task is created, right? So as soon as the task is created, then this task will be assigned to a worker to execute the task. Let's say it is a select query, simple select query, select star from table, or it can be anything, right? So you just open a login connection, right? So even a login, it has to go through this. So this is the so high level or low level architecture of your query execution. So it will be created at it considered as a request, and we will be assigning that request to a task, right? So the task will be created and the task will be assigned to a worker and thread, right? So these two are two parts, because worker you can consider it is a logical thread. So logical thread is nothing but worker. We call it as a so thread in SQL terminology. In SQL Server, we call it as a worker. This thread is an operating system level. We consider this as a thread. So that is the reason worker and thread both are same. So that is the dotted line. Worker is a SQL logical thread. Thread is a physical where it execute the task in the on the CPU, right? So right. So this thread will be created, or this task will be assigned to a thread, and then we consider this as a connection. So this thread will execute on the CPU, right? So session will be created as soon as a thread is started create. I mean, as soon as the thread is allocated to the task, a session will be created. Then only you see that SPID, right? So session ID or whatever it is, that session will be created, and this thread session will not execute or connection will not execute, right? So session is just a logical to SQL Server. This thread will execute on the CPU, right? So any questions? So this we will talk what this task, what this request, what is this and all here, right? This is how your query executes whenever you open any request or any query, right? As I said, like a task is a representing the work that needs to be performed, right? So this is a whatever task, whatever work you are going to execute, that we consider as a task, right? So it will be assigned. A task contains one of the following events, right? You can consider any event, either it is a login or it is a query or it is so any distributed transaction or anything you consider as a task, right? Worker or worker thread. This is the logical SQL Server representation of a thread, right? So thread we call it as call it as a kernel or Windows level operating system level, whereas worker we consider it as a SQL Server level, right? So workers are humble servants, whoever carry the task assigned to them by a master, that is a scheduler, right? So that's fine. So worker is nothing but the task executable task, right? Whoever executing your task we consider as a work, right? The request is a logical representation of a query request made from a client application to SQL Server, right? So first, initially request will be created and request will be assigned to the task, and the task will be assigned to a worker to execute our request. This query request has been assigned to a task, see, that a scheduler hands off to a worker to process the represents query request as well as system threads operating. So whatever we discuss, that is what it is meant to be, right? It can be anything. See here, the checkpoint or lazy writer or any of the system threads, any of these operations also, it will be assigned to a worker to execute, right? It is a connection where we consider it as a physical connector, right? So session is a logical, again I said session is a logical which is only relevant to SQL Server. So Windows communication, like whatever connection we made from application to the SQL Server, that is a physical connection will be established once the thread is or worker is allocated to that particular task, lower protocol, whatever. And this is the understanding how the task or how the so works. right? So for any questions? Okay. Um, so we'll discuss few more terminologies, then we'll jump into further discussion like how scheduling works and all. For now, understand so about the affinity, right? So why this is affinity is required. This is again Windows and SQL I would say, like so SQL Server and Windows uh, relationship, so that queries whatever we